All right. Hey, can you hear me? Perfect. Yeah, great to see everyone. Welcome. Sorry. Oh, we don't have the mics for panelists. Should I just speak for 30 minutes? They can stay quiet. I think, is it me? Okay, perfect.
This room was so much more packed for the DA panel. You hear ZK and the room empties out.
Sorry?
The room was so much more packed for the DA panel.
Yeah.
They said ZK and everybody emptied out.
Next year, next year.
I know.
All right, let's get started. So great to have a great set of panelists here. The topic for today's conversation is ZK coprocessor. Before starting, maybe a quick round of introductions from our fellow panelists. Marcello?
I need another coprocessor. Hello, everyone. My name is Marcello. I'm founder of Herodotus. At Herodotus, we are building, you can probably call it a coprocessor. We really believe that we don't see a huge innovation in the application space because of the limitations imposed currently by any virtual machine running on any stateful blockchains. For this reason, we build an off-chain system that allows you to run provable computation on provably on-chain data, arbitrary computation. So yeah, I'll pass it over. We're pretty short on time, and the list of questions is pretty long.
Hi, everyone. My name is Mo. I'm a founder of Brevis. Brevis is a smart ZK coprocessor that scales blockchain with two things. One is asynchronous computing architecture. The second is off-chain verifiable computing. So concretely speaking, today you can already use Brevis to build smart contract in the new side of application that leverages historical on-chain data and do computation on them and directly use these results in your smart contract in a trustworthy way. So yeah, glad to be here.
Awesome. Well, good afternoon, everyone. My name is Ismael. I'm one of the co-founders of Lagrange. We also built a ZK coprocessor, as is evident from the title of this talk, or this panel. We have a very unique approach that leverages a number of innovations in core cryptography and authenticated data structure design to really be able to scale computation over on-chain data and scale blockchains in a way that we think is fundamentally novel. In terms of what makes our approach to ZK coprocessing unique, well, we allow you to define query-based computation in commonly understood or used languages like SQL, and to be able to verify the results of those computations within your contracts. We're in production now. We have, I think, 2 million proofs we computed over the last 60 days, 90,000 unique on-chain queries, working with some of the big DeFi teams in the space, as are many of my esteemed panelists here. So yeah.
Great, yeah, thank you so much for that introduction. Hello everyone, my name is Raghav and I'm going to be moderating the panel. So let's just kick off. You made the introduction, you talked a lot about processor, cryptography, ZK. There's a bunch of things that we need to start breaking down. So I'll start with the basics, right? Smart contracts already enable some sort of computation, arbitrary computation. That's what the transition from Bitcoin to Ethereum. So maybe starting with you, Marcello, what exactly are we trying different from what smart contracts can already do today?
Sure. So for a very good reason, virtual machines running on stateful blockchains don't have access to history. That's also why we're named Herodotus. He was the father of history. So that's one thing. We don't get access to this historical data, which is a huge limitation when you think about it. Like the amount of applications and innovations you can create on-chain is extremely limited. And even though we are able to access this data, might cost you cents, right? But multiply it by thousands of data points, it's still gonna be expensive. So it feels absolutely natural to just offload this computation, because at the end of the day, your smart contract will care about some specific data points, say, hey, maybe an average. But does it really care to see all the intermediate data points that we're used to compute it? No.
Anything else?
Yeah.
Oh, go ahead.
Oh, yeah, sorry. So I think to understand the motivation of building ZK coprocessor, it's very helpful if we do analogy and look at how internet evolved in the last 20 years. Right. So internet, your internet application or Web2 applications before 2000s are built in this synchronous-based architecture where you have a single server that handles everything. So every user comes, the server does everything and return result. The user leaves the user gets the result. So it was very clear this type of synchronized architecture does not really work and cannot handle the growth of internet users. This is why in modern internet now we have something called asynchronous-based architecture, where the web server itself is going to be a very, very thin piece of software that is just acting as a coordination point between different specialized backend services, such as authentication, data mining, and all that stuff. And this is how we scaled the internet and Web 2 in the last 20 years. Because now we have a way to offload a bunch of computation through asynchronous calls and then receive the result as callbacks and assemble the result collectively to the end user. This is how you're using YouTube, Facebook, X, and all these today. So if you look at Web3's status today, we're still very much in the synchronous era, where, as you said, smart contract can already do a lot of computation, but it is doing the computation as if it is a synchronous web server. It's Web3 server, basically. And it contains all the computation in its own smart contract logic. And because the fundamental limitation of blockchain, even with layer 2 scaling, we're still bounded by the consensus overhead of the underlying blockchain, which means that the kind of computation you can do, the kind of capacity you get, is not going to exceed a single server. So this is why we need to also just borrow the same concept of the internet evolution to introduce the asynchronous design, where the smart contract themselves can start to invoke off-chain computing resources, even at a concurrent, in a concurrent way that, basically say, okay, now I need to do some very heavy computation. This is where I will send out the computation task to someone else. That guy does the computation and put the result back. Now, the reason that we all have ZK here is that we want to make sure that the flow is end-to-end secure and trust-free to ensure that the entire computation cycle does not depend on any other security assumptions other than the blockchain consensus itself. So this is why we really need the ZK coprocessor to scale the next generation of Web3 apps.
Thank you, Mo. Thank you, Marcello, for those great explanations. I want to make a little bit more of a meta point. So, for the last 10 years, we've been asking the same question in crypto. And this is, how do we scale blockchains, right? The majority of the approaches we've seen are the development of a new consensus, the fragmentation of execution and state across rollups, and all of the accompanying complexities that creates for our ecosystem as we do this, right? We've tried to replace rather than augment. ZK coprocessing at its fundamental level is a new paradigm for scaling blockchains. It is taking applications, application-level builders, who exist on existing execution spaces, Ethereum, OP rollups, ZK rollups, et cetera, and giving them access to a new toolkit to let them scale the computation their existing contracts can access. From a technical standpoint, there's a lot of ways to embody that. You can embody that through query-based computation, through computation of historical data. You can embody that through just expressive execution environments like many of the ZK VMs. But at the core, that's what we're trying to answer. We have applications that exist today that have limitations in how they can be built because of the computational constraints of the chains that they're on. Instead of telling these applications to go deploy somewhere else, to go be on a new rollup, to go be on a new L1, we let them stay exactly where they are, and now to scale a little bit more, to do the things that in theory they could do elsewhere where they already are.
Sure, yeah, thank you so much for that clarification. One thing I believe which was common in all three of your answers is, to a certain degree, we are trying to scale what we already have in a cheaper way, right? Smart contracts can do the computation, but we want a cheaper way of scaling the computation, right? Why is this a new term, processor or coprocessor? Why is it that when I say scaling solutions, only layer 2s or rollups come to mind, and why not ZK coprocessor? So I would like to understand a bit in specifically what is the difference between a layer 2 scaling solution and a ZK coprocessor? Is it to do with statelessness, or if you can expand a bit on that?
I think the first fundamental difference is that coprocessors are stateless.
Okay.
We don't create our own state, right? Whereas layer 2s effectively do. That's the first fundamental difference. Then liveness, I think that it's not such a big of an issue because censorship, we don't really see that many applications might require that. And also, like layer 2s, they're starting to address it. In the case of ZK coprocessor, do we need it? We'll see. But I think that statelessness is the biggest difference. And also, you can have some aspect of privacy in the case of ZK coprocessors. Whether on a layer 2, it can get pretty tricky.
Got it. So essentially, it's stateless scaling and optional privacy is something that we are getting with ZK coprocessor. Coming to the aspect of stateless, there's a huge debate, not a debate, but focus from the Ethereum Foundation to figure out the state bloat problem. I would love your perspective on, is this something that ZK coprocessors could help solve in any way? Is there a way where we could offload existing combination to ZK processor and help solve the state bloat problem? Is it something that you guys have thought about, maybe Mo and then Ismael, about this?
Yeah, I mean, so I think for the stateless versus stateful discussion first is that I would actually think that the layer 2 rollups is just the first generation instantiation of ZK as coprocessors, blockchain coprocessors, right? So it is very very specialized coprocessor that offload a bunch of states to a layer 2 construct to a trust-free execution environment, and it scales the states. The focus is actually more about scaling the amount of state you can store on a layer 1 blockchain. And now we're entering in this new era where we start to introduce more and more generalized coprocessors, and to do not only just replicate what exactly layer 1 can do, but also expand on not just the blockchain VMs, but the powerful computation paradigms such as ZK-ML, very heavy data-driven computation. You can compute over historical on-chain data points like events, transactions, and storage state, and derive very useful insight for them, and put that back to the blockchain. Now, is ZK coprocessor stateless? Well, I think stateless or stateful is about how you actually use these ZK coprocessors.
Okay.
Right. So you can imagine that you have some ZK coprocessor computed some intermediary state and store that state just like a rollup committed state root to the blockchain, and then some other ZK coprocessor computation process can actually pick up that intermediary state and run some other computation. Let me give you a very good example for that, right? So one is that if you let's say you want to run some ZK-ML computation based on a vast amount of on-chain data. Now, what you can do is that you can first find some ZK coprocessor or special instantiation of that is handle and can quickly process, scalable process the input data. Right, so it then can generate a attestation of the input data itself and store on the blockchain with a Merkleized root to indicate that this is like kind of a root, and then relay that and compose that with a different type of computation stack. So I would say we're just in the very, very beginning ages of ZK coprocessor. In the future, I really see rollups as just a special first instantiation of that.
Yeah, so I like a lot of the points made by Marcello and by Mo here. Firstly, I think most ZK coprocessors now are stateless, though that doesn't strictly have to be true. In the case of Lagrange, there's certain things that we do that create intermediary state that allow us to optimize query performance. And that's something that we can, in fact, have as a retained data asset within our network that does the co-processing. And then, the point that Mo made, I very much agree that generally, we look at these, and for the case of ZK-ML and the case of large-scale compute over pre-processed data, the ZK coprocessors are highly relevant for that. One thing I also want to touch on that Raghav mentioned at the beginning was why ZK coprocessors are typically thought of as a developer tool. Right. They're typically referred to as something that a developer grabs and uses once, twice in their application, but they're not thought of as a scalability solution. People don't say, this coprocessor scales the base layer. They don't ask, does this chain have the capacity to do co-processing, when they ask, can it scale to the application requirements of what they might require? And that's partly a branding issue, right? I think the earliest embodiments of ZK coprocessors were somewhat limited in the scope of what they could offer. This is a nascent sector, and it's a sector that's gaining prevalence, but it's one where the consumer awareness of it still looks at it as just a middleware, just an oracle. Foundationally, what it is no different than the early inception of rollups. It's a way to take what is and allow you to scale what users can do with it. And that's something I think that hopefully, as more people listen and kind of read about some of the great work done by Lagrange and many of the teams on stage, they'll also begin to develop an awareness of, and the categorization of co-processors will become a little bit more clear.
So specifically drill it down to the point where you said it's not just co-processor, it's more of a scaling solution, and rollups are in fact a specialized use case of co-processor. if we start from a clean slate, would you still call them coprocessor, or in your head, within your internal discussions, you call them something else? Ismael,
Yeah, I can answer because that was directly referencing one of my points. But in my view, the main differentiation between a rollup and a coprocessor is where the transactions are sequenced.
Okay.
A coprocessor, and all the embodiments that I'm aware of, transactions are received and included in blocks on the L1 or on the execution environment, and events are emitted or some trigger occurs such that the coprocessor generates a proof of some computation that's then verified back at a future point asynchronously. And so that paradigm of not separating sequencing from the base layer, but separating execution from the base layer is what fundamentally makes a coprocessor different. Also, I would say that the fragmentation of liquidity, the fragmentation of assets, and the separation of state is also something that differentiates coprocessors from rollups. While you can have intermediary state, fundamentally the intermediary state is a mutation of the base layer state.
Right.
It's not something that's entirely exogenous from the base layer, where the state transition is enforced in the base layer. It is a mutation, not a replacement.
Sure. Would you like to, call different terms, like he explained what the difference is, but you would still call them coprocessors, or would you want to come up with a new term, or you think there's something that better defines these properties of the coprocessor?
I think that there is a fundamental difference because in the case of layer 2s, it's literally like a separate blockchain in a sense that just derives the security of Ethereum. In the case of ZK coprocessors, do we produce blocks? No.
Okay.
Do we produce our own state? Yeah, maybe intermediary state to facilitate the computation itself, but you don't build applications, right, that are running on a coprocessor. They might use a coprocessor, but...
Right, so my application still lives on L1, L2, and yeah, we're still using coprocessor. Coming to the applications part, because I think that's what everyone is dying for at ETC. There's so much infra, where are the apps? So I'll go with two questions. One, which is the application you think is feasible as of today, like based on the infrastructure that you guys have already built, or it will be implemented in the next 2 to 3 months? In the short term, what is one application that you would love to see built on Herodotus, Brevis, and then Lagrange? One application that you would like to see.
I think that one thing that we are really excited about and was absolutely unthinkable maybe 3 years ago. How many of you write some Solidity or can read it?
We have a good
cool.
Solidity test,
Imagine doing a big loop and iterating over a lot of data to compute some reputation. If you were about to say that 3 years ago, you'd just be called crazy. Today, it's actually doable and something we're really, really excited about, because this would simply enable new applications, but also new infrastructure, and very likely the landscape of application in the space will change a lot.
Got it, yeah. Mo, one application you'd like to get built today? Like, if I'm a dev, you tell me this is what I need to build.
Yeah, definitely. So what Brevis enables right now is that it enables the widest kind of data access you can get, including transactions, events, which is like user interaction, and then storage states. So and on top of that, it's not just only state access, right? So then what you can do is that you can actually do arbitrary computation based on these states. So we provide very high-level APIs such as MapReduce, group by source, zip, filter, and all the arithmetic APIs, so that you can actually kind of derive a lot of interesting insights from these data points. Okay. Now, what you can do with this is that the one category of use case that I'm very excited about is now, instead of so if you look at smart contract today is kind of dumb in terms of data access. Right. It cannot really access historical data. Like a user did a trade on Uniswap, a smart contract cannot see in the past. And a user holds a Bored Ape NFT and transferred it to someone else. And if you look at a smart contract executing a state right now, the smart contract cannot see that, right? But what you can use a coprocessor and Brevis for is you can start to access in your smart contract directly these historical state in the smart contract and these historical user interactions. And with that, you can build a lot of exciting things, such as data-driven DeFi, which essentially dynamically change the DeFi protocols parameters, such as fees, such as farming reward distribution, such as risk parameters, dynamically based on historical value, historical interactions of the user or historical state of
Can I just drill down a bit?
Yeah.
One specific parameter, one specific application.
Yeah, definitely. Yeah. So I think everyone can just look up the recent Uniswap Foundation hook incubator. So Uniswap is launching the V4 hook, and they recently launched the Uniswap hook incubator program that you can build different data-driven hooks. And there are already a lot of users that build Brevis-powered data-driven hook that do dynamic fee based on user trading volume or dynamic fee based on volatility of a different pool. So you can have LVR largely mitigated for many of the scenarios. So yeah.
Got it. So this is something that I can build today if I want.
Yes.
Okay.
Right now.
Yeah, so I think this is a very good question. It's probably one of the most important ones to answer. In a word, personalization. I think one of the things that we have been robbed of in crypto is the ability for on-chain applications to personalize themselves for us. Everything we use in Web 2, from our banks to our social apps to experiences in games, has personalization baked into its fabric to allow us to be retained, to hook us in and to keep us there. In crypto, every dApp that exists doesn't have the capacity, because of computational limitations, to personalize for us, to compute over historical storage, events, transactions, et cetera, what Lagrange supports as well, and to have a rich on-chain experience that is aware of how we've previously interacted. And this is from anything from DeFi to GameFi to GambleFi to really anything you can do on-chain, NFTs even. And that's what Lagrange is very excited about. We recently deployed in production, as I mentioned at the beginning. We've been very lucky to have some of the best operators in the space run our provers, Coinbase, Kraken, OKX, et cetera. And we've served 83,000 queries so far to a lot of on-chain applications that have been requesting compute and personalization experience for their users.
Yeah, when you say these numbers, so many thousand proofs, is there an application which is today personalizing the user experience based on what you just described? Because you said personalize. Yeah.
It's
I would love to
personalization.
try that app. Which any names that come to mind?
Yeah, I mean, we were doing stuff with Gearbox. We've been doing stuff with a number of marquee NFT projects.
Okay.
We've been doing stuff with a few other DeFi apps that we'll announce soon. So stay tuned.
So hopefully next
year,
year.
you actually go online right now and run these queries. It's in production.
Perfect. So next year, hopefully, this is just a beginning, but next year, if you're having the same conversation, you guys can tell me, this is a DeFi. We'll be in a world where DeFi applications are highly personalized and customized, because all three alluded you to the point that you could use user history or the current volatility or personalization to offer those better experiences. So I think this enables the UX challenge that we have all been chatting about, that we need better UX. So the sense that I'm getting is your solutions could enable better UX in the near-term future, and it's not like a distant dream anymore.
Yeah,
absolutely.
And I mean, to your point, I would suggest anyone here who's interested actually go and try all this stuff.
Yeah,
try Lagrange, try Brevis, try Herodotus, and see what you think. See what you can build.
Perfect. So far, all the questions that we've been asking and discussing, kind of moving in the same line, same thought process. Would like to spice it up a bit, where the differences come between Lagrange, Brevis, and Herodotus. And correct me if I'm wrong, but as far as I understand, Herodotus is using Cairo and on-chain accumulators. Brevis, along with ZK, also has partnered with Eigen for optimistic security. And Ismael, if I'm not wrong, you're not using on-chain accumulators and you don't use economic security, right? I'll let you correct those in game. So let's maybe, Marcello, quickly, why Cairo, why on-chain accumulators, and why do you think is the best approach? And at the end of this question, I would really appreciate if you guys have rebuttal or differing views, because that will help everyone understand what approach works.
Sure. So first, I would like to clarify what an on-chain accumulator is. Okay. As we spoke before, it's basically like creating an intermediate state that just facilitates the computation. So to maybe visualize you the problem, why we actually had to design these solutions. When you're a Etherscan and you want to access some information, I know you want to see the gas used in some specific block, you just select the block and you paste it to Etherscan. You don't just keep clicking, -1 until you reach it. That would be really inefficient, and we don't want to do the same computation off-chain. So this is why we came up with such a solution. So again, it's an intermediate state at the end that we use there. Regarding why Cairo, it's highly optimized for what we do, specifically. Literally everything on Ethereum today moves around Ketchaks. It's pretty good at Ketchaks. The performance of the upcoming Stu prover is highly impressive, and we simply want to piggyback off this ecosystem and also, contribute to it and build on top of it.
Okay, perfect. Mo, your take on, why coupling cryptoeconomic security along with ZK when ZK, I believe, is giving you good enough verifiability.
Oh yeah, sure. So I think if we're comparing different solutions, I wouldn't claim we're the best or anything. I would just suggest that everyone, when they're comparing different ZK coprocessor solutions, to compare on 2 points. One, how you can use this. Like, what is the type of data you can access? It's the event, the transactions, the states, all of that. And the second, how you can run computation on top of that. Right? So like, what is the type of computation you can run? What is the paradigm of a computation? Which one do you think is more comfortable with you? Right? So I would say, from a developer experience point of view, you guys can look at the docs first on that front. Right? So that's the first aspect. Now the second aspect is what are the trade-offs offered by different solutions?
Okay.
Right? So for Brevis started building. So when you're talking about ZK coprocessors, the most straightforward way to do this is run everything in ZK.
Okay.
And this is indeed how Brevis started. We started to do everything in ZK, and we have that model available. Right now, the documentation supports that model by default. Now, recently, we introduced something new called an optimistic coprocessor with ZK fraud proof. It is very much similar to an optimistic rollup with ZK fraud proof. So instead of doing everything purely in ZK all the time, you have the option now to actually use an optimistic proposer to propose to the blockchain without actually running any ZK proof that this is the co-processing result. And then after the proposal, just like optimistic rollup, you open a challenge window. And during the challenge window, if a challenger detects there's something wrong, it will submit a challenge via a ZK fraud proof. So using this model, what we gave you is the trade-off to have a much, much lower cost, because in most of the cases, you don't actually need to run any ZK computation. Therefore, the type of computation you can run also expanded quite significantly, as well, as a state of art of ZK. And at the same time, you're trading. What you're trading off? You're not trading off with security. Security is still ZK because the last line of defense is a ZK fraud proof. You're trading off latency, so you need to wait a bit, right? So now the reason we use crypto economic security in this process is that we can use a crypto economic security component to act as the proposer for both liveness and immediate security with the crypto economic security. So basically, instead of just having a centralized sequencer like most of the rollups do, now you essentially have a decentralized sequencer that's run by EigenLayer AVS that offers immediate proof of state security. And if some application developers are comfortable with that, they can directly ingest the data without waiting a very much long, latency trade-off. So yeah, this is how we kind of structure this whole thing to offer the widest trade-off spectrum for developers to choose.
Ismael, your take?
I'll share my take. So at our core, Lagrange is a ZK company. We've prioritized fundamental research, and our belief is that scaling ZK coprocessing is created through fundamental innovation. So this year, we published a paper in one of the top cryptography conferences, TCS, about a new vector commitment. We have a new design for a verifiable SQL construction coming out very soon. We have papers on mechanism design. Our team's priority is how can we take first principles innovation in underlying authenticated data structure designs, proof composition, recursive snarks, et cetera, and how do we build products that leverage these innovations in ways that allow end users on-chain to have better experiences. And so I'm not going to argue here on benchmarks. I'm not going to argue here on expressivity. The thing I'm going to state is I think it's very important to be hyper-focused on something. And what Lagrange is hyper-focused on is how can we serve verifiable computation on-chain for the purpose of ZK coprocessing in a way that has high guarantees of liveness and has safety that is derived from the consensus of the verification blockchain. This is why we don't use accumulators. Every proof verifies against the block header of the chain that it's verified against. And so that's Lagrange's stance. That's where we are. And once again, I don't want this to become a benchmark jockeying contest. So I really think the best way for anyone here to kind of get involved is really to play around with these things. We all have stuff out on this stage right now. We all have ways you can use our products. And so I think that's the best way to kind of become involved.
Sure. So we're not discussing benchmarks. If you want to make up your mind, please try Lagrange, please try Brevis, please try Herodotus. Come to your own conclusions, and we have clearly listened to some of the trade-offs. We are almost at time. We'll just take one quick question, if there's any from the audience. I think either we did a really good job that everyone understands everything, or
I have a question for you, Raghav.
Oh, really? Okay.
What do you want to build with a ZK coprocessor?
What
would you build?
What would I build?
What would you build?
Yeah, as you said, I'm interested in building a hyper-personalized application, as you guys have already mentioned, and I wrote about this as well, sometime back on an article that right now everyone goes to an application which seems exactly the same to everyone, and I would like it to be customized exactly to my needs. I would love if it could be customized to my previous transaction history. I would love if it could be customized based on, if I could run some AI agent behind the scene to figure out what I'm most likely to do, and based on that could offer me a lot of personalization. So yeah, I'm not sure if I have the talent to build that application today, but I do advise, I work with a lot of devs, so maybe they'll build something on the platforms that you're building. Thank you so much, everyone, for your time. Maybe just one final thing, what's the one hot key takeaway from ETHCC this time? Just one line. What excited you? What made you happy? Sunrise, sunset, any ZK thing, or what excited you about ETHCC?
For me, I think it's that there are more builders prioritizing execution spaces than what the things you can do in execution spaces are. And I think that we need to, as an industry, really focus on why we're here. What do we want to do? What do we want to build? And what do we want people to use? It doesn't matter where it's deployed. It matters what it is.
Got it. Thank you. I'm just cutting because we are at time. Just one line each. What excited you? What was the key highlight of ETHCC?
I think that people are seeing that what is possible to do on blockchains is changing, and they're starting to embrace it. That's super exciting.
Got it. Mo, anything?
As always, we need applications, and I think that's also the reason why this kind of a bull market kind of felt shorter than before, right. And it was driven mostly by ETF, and we all know it. But I'm very glad after exchanging with many of the same panelists multiple times that we're definitely pushing towards that direction, and the next generation of amazing user experience is going to be built by many of us.
Great, thank you so much. I guess our priorities are different. My highlight was waffles. I think you guys are still focused on applications, but yeah, great. Thank you so much for your time. It was a pleasure hosting and talking to you.